Hello students, today we are going to learn about a multiplexing and different types of multiplexing. Generally, a communication channel such as an optical fiber or a coaxial cable can carry only one signal at any moment in time. This results in wastage of bandwidth. However, we can overcome this drawback by using a technique called a multiplexing. By using the multiplexing technique, we can easily send multiple signals simultaneously over a communication channel. Now, what do you mean by a multiplexing? Multiplexing is a technique which combines multiple signals into one signal, suitable for transmission over a communication channel such as a coaxial cable or an optical fiber. Multiplexing is also sometimes referred to as a muxing. A multiplexing technique divides the communication channel into several logical subchannels. Each logical subchannel is dedicated to an individual signal. Thus, the multiple signals are sent simultaneously over a shared communication channel. A multiplexing has been used for many years in long-distance telephony. Multiplexing is done by using a device called multiplexer or mux. The multiplexer combines n input lines to generate one output line. Now we can see what do you mean by a demultiplexing. Demultiplexing is a term relative to multiplexing. It is the reverse of multiplexing process. Demultiplex is a process reconverting a signal containing multiple analog or digital signal streams back into the original separate and unrelated signal. That means the demultiplexing is just opposite to a multiplexing. Now, types of multiplexing. Multiplexing is mainly classified into two types, that is analog multiplexing and digital multiplexing. Analog multiplexing is again classified into two types, that is frequency division multiplexing and wavelength division multiplexing. In digital multiplexing, the time division multiplexing is the most popular technique. The time division multiplexing is again classified into two types, that is synchronous time division multiplexing and asynchronous time division multiplexing. Now, what do you mean by analog multiplexing? The process of combining multiple analog signals into one signal is called analog multiplexing. It multiplexes the analog signals according to their frequency or wavelength. The multiplexing requires that the multiple signals be kept apart so that they do not overlap with each other and thus can be separated at the receiving end. This can be achieved by separating the signal in frequency. There are two types of analog multiplexing. They are the frequency division multiplexing and wavelength division multiplexing. Frequency division multiplexing. Frequency division multiplexing is an analog technique. It is the most popular multiplexing technique. We use this technique extensively in TV and radio transmission. This technique combines multiple signals into one signal and transmitted over the communication channel. Frequency division multiplexing is also known as FDM. In this technique, the bandwidth of the communication channel should be greater than the combined bandwidth of individual signals. The frequency division multiplexing divides the bandwidth of a channel into several logical subchannels. Each logical subchannel is allotted for a different signal frequency. The individual signals are filtered and then modulated. That means frequency is shifted in order to fit exactly into a logical subchannels. In this technique, each logical subchannels, that means individual signal frequency, is allotted to each user. In other words, each user owns a subchannel. Each logical subchannel is separated by an unused bandwidth called a guard bandwidth to prevent overlapping of signals. In other words, there exists a frequency gap between two adjacent signals to prevent a signal overlapping. A guard band is a narrow frequency range that separates two signal frequencies. What are the advantages of frequency division multiplexing? It transmits multiple signals simultaneously. In frequency division multiplexing, the demodulation process is easy. It does not need synchronization between the transmitter and the receiver. Now, what are the disadvantages of frequency division multiplexing? It needs a large bandwidth communication channel. Now we can see the applications of frequency division multiplexing. The frequency division multiplexing is used for FM and AM radio broadcasting. It is used in first generation cellular telephone. It is used in television broadcasting. This is a diagram for frequency division multiplexing. The process of combining multiple digital signals into one signal is called a digital multiplexing. Now, time division multiplexing. Time division multiplexing is a technique in which multiple signals are combined and transmitted one after another on the same communication channel. At the receiver side, the signals are separated and received. Each signal is received by a user at a different time. Time division multiplication is also simply referred to as TDM. It is the digital multiplexing technique. In frequency division multiplexing, all signals of different frequencies are transmitted simultaneously, but in time division multiplexing, all signals operate with the same frequency are transmitted at different times. In frequency division multiplexing, the sharing of a channel is done on the basis of frequency. But in time division multiplexing, the sharing of a channel is done on the basis of time. In time division multiplexing, each user is allotted a particular time interval called a time slot during which data is transmitted. The time interval, that is a time slot allotted to each receiver, that is user, is so small that the receiver will not detect that some time was used to serve another receiver. In time division multiplexing, all signals are not transmitted simultaneously. Instead, they are transmitted one after another. The time division multiplexing technique is used to multiplex analog signals or digital signals. However, the time division multiplexing is more suitable for digital signal multiplexing. In time division multiplexing, the bandwidth capacity of the communication channel should be greater than the multiple input signals. What are the advantages of time division multiplexing? Full bandwidth is utilized by a user at a particular time. The time division multiplexing technique is more flexible than frequency division multiplexing. In time division multiplexing, the problem of crosstalk is very less. The disadvantages of the time division multiplexing are as follows. In time division multiplexing, a synchronization is required. Now, wavelength division multiplexing. A wavelength division multiplexing is an analog technique. It is the most important and most popular method to increase the capacity of an optical fiber. We know that the wavelength and frequency are inversely proportional to each other. That is, longer wavelength means low frequency and shorter wavelength means high frequency. Therefore, the working principle of wavelength division multiplexing is similar to frequency division multiplexing. The only difference is in wavelength division multiplexing, optical signals are used instead of an electrical signals. In wavelength division multiplexing, optical signals are transmitted through a fiber optic cables. A wavelength division multiplexing is a technology in which multiple optical signals, that is a laser light of different wavelengths or colors, are combined into a one signal and is transmitted over the communication channel. Thus, multiple signals are transmitted simultaneously over a single communication channel. A wavelength division multiplexing is a technology that increases the bandwidth of a communication channel, that is optical fiber, by simultaneously allowing a multiple optical signals through it. In wavelength division multiplexing, the communication channel is a fiber optic cable. A wavelength division multiplexing is also known as a WDM. A demultiplexer at the receiver end separates the optical signal wavelengths or colors. In this technique, the bandwidth of the communication channel should be greater than the combined bandwidth of the individual signals. Advantages of wavelength division multiplexing. WDM allows a transmission of data in two directions simultaneously. It's of low cost, greater transmission capacity, high security, and long distance communication with low signal loss. The main differences between the FDM, the WDM and the TDM I will explain you in the next video.